Thank you. Hello. So I got something like 20 minutes for a 60-minute talk, so this is going to be pretty, pretty fast. So let's start at the beginning. More enterprise Unity development with UniRX and MVPToolkit is the title of my talk. As you can see all of my ways to contact me over there. So I will show the slide at the end if we get to the end, and you can take pictures then. But let's start with what this title means. Let's talk with enterprises. So we're not talking about the StarTech enterprise, unfortunately, today. We're talking about big companies with a lot of money and a lot of regulations around their internal softwares, all of that boring stuff. And we're talking about applications, XR applications that these companies need. For example, here's a sample where a first-line worker is learning how to put together an engine, and she's wearing a HoloLens, and this HoloLens is showing her where to put the different parts of the engine. For another project that I've worked on, this is probably one of the largest projects outside of Microsoft using Microsoft HoloLens, where the idea is that or the user is an aircraft engineer working on actual aircraft. Aviation safety is key concern. And what we have here is a digital representation of not just the different parts of the aircraft, as you can see, but all the little damages on the aircraft, which basically determine how much service work is needed for that plane to actually fly again. And a lot of this is actually done in paper or maybe iPad tablets these days, but we have developed a HoloLens-based solution for that. So this is the kind of enterprise applications that we're talking about. Now, if you're an enterprise and want to use one of these fancy headsets, then what you know is, okay, this looks cool, so let's create a pilot project. Let's hire somebody who knows how to program these things. And when you look at look it up how you can program these things, one of the things that come up is usually Unity. So if you want to program HoloLens, you have to, not have to, but you're best off if you do it in Unity, and Oculus and all the others. Unity is a pretty strong player over there as well. So what you're gonna do, you're gonna put out an advertisement. I'm this and this big company, and I want to hire Unity developers. And this is where the problems start. So let's play a little game. Let's see what an application, an enterprise application versus a game developer thinks like, and what they say. So if I'm an application developer, I'm gonna say, I want some serious stuff to do. If I'm a game developer, I'm gonna say, I want to have fun. I want you to have fun, right? So that's the difference. And the application developer says, my users are going to use this every day. It needs to be easy to understand. It needs to be easy to learn. It needs to be, it is a tool. It's not a toy. If your game developer is going to say, well, what do you mean it shouldn't be fun? I mean, part of writing a game is making it difficult but rewarding to find secrets, right? So there's again a difference between the two. The application developer, the enterprise guy is going to say, I want maintainability. I want this application to be able to function 5-10 years from today. The game developer is going to say, well, I just created a cool casual game for my iPhone. I'm going to release it to the store, maybe patch it once or twice, and that's it. I'm off to the next project. Oops. And then, as I said, 5-10 years support is the normal for enterprise applications. So that means that you're going to make architectural decisions based on this. The game developer is going to make architecture decisions based on performance, because every tiny bit of performance can make the game that much faster, that much more fun, that much better looking. So yeah, I'm going to squeeze out every little bit of performance from the hardware, even if it means that my code is not going to be readable as much. It's okay. It's just one release. It's just one project. So I'm not going to diss game developers. I love gaming. This is just part of my Steam library. There is hundreds and thousands of hours that I do play. But when I'm working with companies, we have to do something differently. And also, Unity is a game engine, which means that the engine itself has a game-oriented architecture. It is never heard of something like 5 or 10 years of support. The long-term support of Unity itself is 2 years. So that means that if your application is going to run for 5 years, that means at least 2 major version upgrades, which is super painful in Unity. And the workflow is, again, game-oriented. So what do enterprise development needs? What does it need? It needs readable code. I don't want to spend my next 5 years working on the same project, so I better write a code that is readable so the next guy, or even if I get fired, then the next guy can read it, and they can understand what I wrote. Readable code is a priority. Testability, creating automated tests, is a priority, so that when you touch the code here, you can be sure that somewhere else it doesn't just collapse and stop working. That comes with maybe test-driven development. And the key thing is separation of logic and presentation, which means that the logic of how things work, the kind of data that we're working on is going to stay the same, but maybe my application is going to run on 2 or 3 different headsets during its lifetime. So that means separation in architecture and also in the workflow of how we're doing stuff. And I don't know if you've heard about this, the pit of success. The pit of success basically means to create an architecture where every developer is having a really hard time doing bad stuff, but it's much easier to do right stuff. So as an architect, you have to make sure that your developers fall into this pit of success, and it's very difficult them to do harmful things. So let's start with the first thing, the separation of logic and presentation. What does that mean? I'm going to age myself. This is a handheld console from the 1980s, I think 1983 maybe, where you drive a little tank on a bridge, and airplanes are throwing bombs over you, and you have to jump between the bombs and exit on the right side to escape this bridge. Don't ask me why the bridge doesn't collapse with all the bombs. This is just a game, okay? And now here is another game. There you go. Oops. Which has exactly the same logic. It has exactly the same code, so to say, and I can even play it for you. I hope. Start. That's the one. So I can play it, and instead of a tank, I'm impersonating a little guy on a boat, and instead of bombs, I have all kinds of other dangers that I have to escape. But it is exactly the same code. The difference is the graphics. The drawing is the difference. So if we come back to the presentation, I hope you saw that. Oh, damn it. I just realized that you may have not seen it. Okay, so you saw this. You can imagine this guy running up and down. I don't have time to show it. Yeah, let's try and duplicate. Maybe now. Yeah, there you go. Okay, game, start, quickly. This little guy is running, and instead of bombs, we have birds and sharks and whatnot. Okay, exactly the same logic as before. Phew, next thing. And now I have to do this, right? Yay. Okay, so it has exactly the same logic because, come on, PowerPoint doesn't like all of this trickery. There you go. Okay. So this is the code that they had. It's basically, if you zoom into the little chip inside, this is extremely difficult to change. This is extremely difficult to modify and to tweak, unlike the graphics, which is just, what kind of LCD you add to that. So that's what I mean by separation of presentation and code. So let's talk about the other parts of my talk title. This is a really cool title because it has basically the topics of this talk, the UniRX. UniRX is a port of the .NET reactive extensions. If you know that, then you're gonna sigh a relief. If you don't, I don't have time to explain it from start, but I'm gonna show a little bit of code in the second part. This is a port for Unity where you can use reactive programming. You can install it from the asset store. It's pretty old and it hasn't been updated, but it still works. And open source if you find some bug that you may run into. So I can wholeheartedly recommend you use this in your architecture. And the last part is the MVPToolkit. This is another open source project which I have published, I have created, and it supports some of the things that I've been talking about so far and that I'm going to show you as code just right after the next slide. So these two together is something that we use in pretty complicated applications like the airplane one that I showed before. And it's code time. Okay. Let's see. Code. Unity. So here we go. This is the Unity editor for those of you who know it. Those of you who don't, this is not going to be a Unity course, unfortunately. I can't teach it this in 13 minutes and 45 seconds. This is a light switch, and I can just click on the switch and it flips. Awesome, isn't it? I see some of you have just, got blown away. I can even use touch. The interesting thing about this is that I can show you some of the architectural paradigms that I was babbling about earlier. So the light switch, basically, when you talk about logic and presentation, it has, in terms of logic, it's basically a bit. It's either on or off. That's the logic. And you can toggle between the two, maybe not. And when it comes to presentation, can you see the code somewhat? Maybe it's better this way. Let's have a very, very quick look. So the important part is this guy right here. I'm going to be fancy. This guy right here. It's a presenter base. The architecture we're using is a model view presenter, and I'm going to explain what all of those is. So this is going to be a presenter part, and what we are presenting is, I can draw arrows, is a Boolean reactive property. This is coming from the UniRX framework, and what it means is that this is a Boolean property, meaning it's either on or off, true or false, and it's reactive, which means that you can basically subscribe to any changes that this property has. And this subscription is key to this reactive programming. So what we're doing right here is very, very simple. Here, again, here, we're subscribing to the changes of the value of the model, true or false. We're going to subscribe to that, and once we subscribe to that, depending on whether we switch to true or false, we're going to change the rotation of the inner part of the switch. That's it. I think even if you're not a programmer, maybe you can get somewhat of a grasp of what I'm talking about here. So this is how we separated the logic from the presentation. Now let's go a little bit further. Why is this cool? This is cool because I can also do stuff like zoom, yeah, there you go. I can also do stuff like when I click on the button, I shouldn't zoom in, Okay, let's start again. When I click on the button, you can see here that the model has been ticked. It's on. When I click on this, then the switch is going to turn off. So there's a bidirectional connection between the two with minimal amount of code. Now, I have a more complicated demo to show you as well. It is also going to be extremely complicated. Let me start this, and if I press the space bar, I'm going to have a light switch. Yay! As I press the space bar again, I'm going to have another light switch. And these two light switches are basically working like the hallway switches, so if both are up, then the light is on. If both are down, then the light is off. And I can have as many switches as I want, and only when all of them are in the same state is when the light is on. And I can even remove them. So how would you go creating this, again, fantastically complicated application in using the MVP model? Well, what we have first is something called a main model. The main model is the main application, let's say, and we have here something called a reactive collection, which means that it is going to react whenever the collection is changing. And inside the reactive collection, we have little bits, these Boole reactive properties, yes or no, yes or no. And whenever I add a new item to the reactive collection, which is going to happen right here, whenever I add a new item to the reactive collection, I don't care about whether it's a light switch or a button or, I don't know, a door that is open or closed. I don't care about that. All I care about is it has two states, yes or no, true or false. And I'm going to add a new one here in these three lines, and I'm going to be able to remove them. Basically, this is the key line. It's going to remove the last switch. So what is happening right here? What is happening is that whenever the number of switches changes, that's here, whenever that changes, we're going to update the light. Whenever a switch's state is changing, which is right here, we're going to again update the light. And the update light is basically just a short expression saying if there is every one of these is true or every one of these is false, then the light should be on, otherwise the light should be off. So that's how the code is done. But the interesting part is none of these said light switch, none of these was talking about light switches, it's just talked about on and off states. And now I can do tests. I can test this logic. I can say, well, let's test the logic that adds a new light switch. How am I doing that? When I'm launching the application, I should have empty, which means there is no light switches. I'm adding one, so I should have one. I'm adding another one, I should have two. I'm removing one, so now I should have one light switches. And that's all this test is doing. And then we can do verify the light on logic. So initially the light should be off. I'm going to add the light switch, which is always in the same state as all the light switches, so it should be true. It should be on. I'm going to add another one which is off, so the light should be off, and so on and so on. So basically, I write an automated test for this super complicated logic that I just explained to you without even opening Unity. I can do all of this without even opening Unity. And that's the key here. Because the next thing I'm going to do is I'm going to just simply run this application. Ding, 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 ding. Sorry, run the tests. And all of them are green, which is awesome. If you're a developer, you like green tests. And the last thing that I want to show you is how you connect these light switch models. How you create the entire main presenter. So we had a main model which cares about the logic, and now we have the presenter, which is going to say, well, I'm going to create a model. I'm going to init the light so that it is on. I'm going to create a collection of light switches. This bound items container is something part of my MVP toolkit. And whenever the collection has a new item, this bound items container is going to create a new light switch in the Unity scene and place it properly. And that's all the code that I had to write here. The rest is already tested. The last part is just, handling the spacebar and the backspace keys to add and delete the switches. So why does this pop up all the time? So just last slide, I promise, or almost the last slide, which is going to be, I have 4 minutes, 50 seconds left. I can see.
We have questions.
Yeah, so this is the architecture what we're trying to build, model presenter view. The model is the logic and the state of the application. The view is the Unity part, and the presenter is a little pieces of code that tie the two together. And this is the slide. I promise you, if you want to contact me, then this is probably one of the best ways to do this. Or I'm open. Am I open to questions? I am open to questions. Awesome. Thank you.
Thank you so much, András, that you are showing us your code, and by drawing it, it's perfect. Thank you so much. We can have few questions it's your time to have questions now. Okay.
Everybody's stunned.
Any Unity builders in the room? Okay. Maybe they will give it a try after this session.
You can find me later. Thank you.
Oh, we have one question.
Can I ask the question?
Yeah.
Thank you for the presentation. I'm curious about, for this architecture style, if it's highly scalable, and how, what are the applications that deserve this type of architecture? Like, how big they need to be? How scalable?
How big they need to be. So
yes.
A lot of the, if you talk to so-called architects, then they are going to say that you need some kind of architecture like model view controller, model view presenter, model view model. All of these are pretty close to each other. If you understand one, then you probably understand the rest. The key here is testability and the architecture, the bit of success that I talked about. So I would say, in terms of size, if your project goes longer than a few months and takes more than 1 or 2 developers, then you're going to need a more well-defined architecture and development process. That's the whole point. If you hire Unity developers from the street who have only done one-person casual game projects, which is awesome, and they can be super smart, but if they've never seen a project that they have to support for 5-10 years, then they're not going to think about a lot of these traps that you only fall into once your application becomes big. And then that is when you say, well, we have to rewrite this from scratch because there's so much technical depth. Adding any new functionality is going to require so much work that we better rewrite from scratch. And I've seen that happen, and that's why this talk came to be, so that your company doesn't make that mistake.
We can have one last question. Yes, we have it in the middle. Yes.
First of all, thank you for your talk. I have a question regarding the ambiguity. How ambiguous is this to the toolkits used in Unity itself? So, for example, if I use MRTK or XR toolkit for development in Unity, if I support MR, can I just can I use this MVP toolkit to wrap around the logic that I use to build the application itself? So, can I use any type of toolkit in terms of Unity supports towards the device?
Yeah, you can use this approach. We were using MRTK for that project that I've shown, and as a couple of other projects. I've used it for projects that don't use any toolkit like that because they didn't need that. the thing is, those toolkits are usually focused on the view or the presenter layer. So if you architect the model layer and support it with unit tests, then basically you don't have to care about the actual logic of the application. You only have to care about the presenter, which you can change if the model layer is solid.
Okay, thank you.
Thank you so much, András. Thank you.